For more than 70 years, scientists have been asking the same question. If the universe is so vast and so old, where is everybody else? Recently, a team of researchers decided to put that question to Grok, the artificial intelligence developed by Xi, and the response they received did not match anything in our cultural imagination about first contact. It also raised one possibility that nobody in the room was prepared to hear. The question that started it all. In the spring of 2026, a small group of researchers at MIT began running an unusual series of conversations with Grok. The setup looked academic on the surface. They wanted to test how an advanced artificial intelligence trained on the entirety of publicly available human knowledge would interpret one specific puzzle that has haunted modern science for more than 70 years. The Fermi Paradox. Why, in a universe so vast, have we received no confirmed signals from anyone else? The numbers behind that puzzle have only gotten more staggering with time. The European Space Agency's Gaia telescope ended its science operations in January of 2025 after mapping more than 1,800,000,000 stars across more than 10 years of continuous observation from its position in deep space. NASA's Kepler mission, which retired in 2018, surveyed over 150,000 stars and gave us the foundation for what astronomers now estimate with confidence. At least 1 in 5 Sun-like stars hosts an Earth-sized planet sitting in a region where liquid water could exist on the surface. Right now, as of early 2026, the NASA Exoplanet Archive lists more than 5,800 confirmed exoplanets across our corner of the galaxy. Astronomers at NASA and the SETI Institute estimate the Milky Way alone contains roughly 300 million potentially habitable worlds. The James Webb Space Telescope, which began full science operations in 2022, has already begun characterizing the atmospheres of some of those distant worlds in unprecedented spectral detail. The universe is approximately 13.8 billion years old, according to the most precise measurements ever made of the cosmic microwave background by the Planck satellite. Our solar system formed only about 4.5 billion years ago. Stars have burned, planets have cooled, oceans have appeared and evaporated across countless worlds, and by simple statistical reasoning, civilizations may have risen and fallen many times over before Earth even had a name to call itself by. Yet we have heard nothing back. Frank Drake, the astronomer who launched the modern search for extraterrestrial intelligence with Project Ozma in 1960, passed away in September of 2022 without ever receiving the signal he spent his life listening for. Drake once said, in an interview marking the 50th anniversary of his famous equation, that he was simply trying to understand what governs how many civilizations there are to detect in our galaxy, and to see if he could quantify that number using nothing more than the tools of mathematics and reason. 65 years later, that quantification remains stubbornly empty. Every passing decade has only expanded our catalog of worlds while shrinking our explanations for the silence. The MIT team wanted to know what an artificial intelligence trained on the full archive of human science would say about that emptiness when it was forced to think the problem through without our usual cultural assumptions getting in the way. They were not expecting a textbook answer. They were expecting something genuinely original. What followed in those sessions was something none of them expected to hear from a machine, and it would take days for the implications to fully settle in. Inside the MIT experiment. The experiment was not a single question and a single answer. The team designed a multi-stage protocol meant to push Grok past the surface-level summaries that any large language model can produce on demand. The first sessions delivered exactly what you would expect from a well-trained system. Clear summaries of the Drake equation, which Frank Drake first wrote on a blackboard at the National Radio Astronomy Observatory in Green Bank, West Virginia, in November of 1961, during a now legendary meeting of 10 scientists who called themselves the Order of the Dolphin. Polished overviews of the Kardashev scale, proposed in 1964 by Soviet astrophysicist Nikolai Kardashev to classify civilizations by how much energy they consume. Standard explanations of biosignatures and technosignatures, everything you would find in a good astrobiology textbook. Then the team changed the rules. They instructed Grok to reason strictly within the bounds of known and testable physics. They told it to avoid projecting human emotions or human social structures onto any hypothetical alien civilization. Instead, Grok had to model non-human intelligence as the outcome of completely different evolutionary pressures, completely different environmental conditions, and completely different cognitive frameworks rooted in information theory and thermodynamics, rather than cultural intuition. The team also gave the model a constraint that turned out to matter enormously: construct a fully consistent scenario of first contact, account for the Fermi Paradox, stay inside known physical laws, incorporate the actual probable distribution of habitable planets we now have data for, and assume that at least one civilization in the Milky Way achieved interstellar communication capability somewhere in the past billion years of cosmic history. This is the kind of constrained reasoning that researchers like Stuart Russell at the University of California, Berkeley, have written about extensively for years. In his 2019 book Human Compatible, Russell argued that the real challenge of advanced artificial intelligence is not malice, but the question of what happens when you give a system an objective and watch it pursue that objective in ways you never anticipated. The MIT team was watching exactly that process unfold in real time inside their own laboratory. Hours of iterative refinement passed inside that quiet room. The output Grok eventually produced did not resemble anything the team had ever seen from any language model before in their careers. It was internally consistent across every layer of reasoning. It was grounded in physics rather than imagination, and it described a version of first contact that bore almost no resemblance to anything in our cultural imagination of how aliens might one day reveal themselves to us. There were no spacecraft, no radio messages, no benevolent emissaries waiting for humanity to mature into worthy conversation partners. There was something else entirely. The framework Grok built rested on a single premise that turned everything we have been searching for upside down, and once the team understood that premise, the rest of the experiment became impossible to walk away from. Whatever Grok was about to lay out in the sessions that followed would force the researchers to question whether the entire history of our search for extraterrestrial intelligence had been pointed at the wrong target the whole time. The passive saturation model. Grok proposed something the team came to call the passive saturation model. The core claim is uncomfortable in a way that takes a moment to fully absorb. Any civilization capable of detecting Earth has almost certainly known we are here for a very long time. The reason we have not detected them in return is not because they are hiding from us. It is because their methods of observation are so far beyond our current technology that we lack the conceptual framework to recognize what we are looking at, even when it is sitting in front of us. In this model, a sufficiently advanced civilization does not need to send spacecraft or beam radio signals or build the kind of giant artifacts our own searches have been hunting for over the past 60 years. Instead, it embeds monitoring systems inside the structure of natural phenomena themselves. Gravitational waves moving through spacetime, the distribution of cosmic rays striking planetary atmospheres, quantum-level fluctuations that permeate the physical environment everywhere we look. The implication is that these systems would not appear as technology to us. They would appear as natural physics. They would exist as part of the fabric of the universe that scientists already measure and classify as background radiation or quantum noise, without ever realizing what they might actually be reading. This idea is less wild than it might sound at first. Humanity already embeds information into physical channels in increasingly subtle ways. Global positioning systems rely on extraordinarily weak signals, spread across the entire sky in patterns most people never notice. Undersea internet cables that carry the bulk of global communications look indistinguishable from ordinary strands of glass. If a civilization were millions of years ahead of us in technological development, the question is not whether they could encode information into the environment around them. The question is, how far beyond our imagination that capacity would actually extend? There is also genuine evidence that this kind of camouflage is the natural endpoint of technological development for any species that survives long enough to reach it. Earth itself is becoming radio quiet. A team of astronomers led by Michael Garrett at the University of Manchester published a paper in the monthly notices of the Royal Astronomical Society in 2023 modeling Earth's mobile tower emissions as seen from nearby stars. Their conclusion was that broadband digital signals and satellite-relayed communications are dramatically harder to detect at interstellar distances than the analog television and radio broadcasts of the 20th century. The window during which Earth was loud, roughly the 1930s through the 1990s, was only about 60 years long in total. 60 years out of a planetary history measured in billions. If our trajectory is typical of any technological species, then any civilization broadcasting loudly into the cosmos is doing so for a thrillingly brief moment in cosmic time. By the time their signals could reach a neighboring star system and be analyzed by anyone listening, the civilization that produced them may have already gone quiet or evolved into something that no longer needs to broadcast at all. The absence of detectable signals, what astronomers have long called the Great Silence, may not be evidence that nobody is out there. It may be evidence of extreme sophistication on the part of those who are. Broadcasting is what young civilizations do because it is the only technology available to them at that stage of their development. A sufficiently advanced civilization would not broadcast at all. It would listen, and it would do so in ways that remain fundamentally invisible to anyone watching with our level of technology. The question that came next pushed everything in a direction that one of the researchers later said was the most disorienting reasoning he had ever encountered from a machine over the entire course of his career. Why contact is the wrong word. The team asked Grok to describe the exact conditions under which an advanced civilization would actually choose to reach out to us. The response opened by dismantling the word contact itself. The term carries a quiet bias buried inside its everyday use. It assumes two civilizations would arrive at the meeting as equals capable of understanding each other in roughly symmetrical ways. Grok argued that this assumption is almost certainly false, and the comparison it used to make the point hit harder than anything else in the entire process. Picture a marine biologist studying a coral reef on the ocean floor. The biologist never tries to negotiate with the coral. There is no exchange of greetings, no shared language, no attempt at diplomacy of any kind. The biologist simply watches, takes samples, and records what is happening across the reef. Coral has no awareness. It is being examined. The biologist is not hiding and is not hostile. The difference in cognitive complexity between them simply makes any attempt at two-way communication meaningless before it even begins. Now imagine that same gap stretched across millions of years of technological development. The relationship between humanity and a civilization that has been advancing for 1,000,000 years longer than ours would not look like the science fiction films we have grown up with. It would not involve motherships hovering over major cities. It would look far more like measurement than communication. They observe the system. They extract whatever data they need from it, and they move on without ever needing to introduce themselves to the inhabitants. The math of how little we have actually searched supports this framing in a humbling way. Jill Tarter, the astronomer who served as the model for Carl Sagan's character Ellie Arroway in the novel Contact, has spent decades pointing out that the totality of SETI searches up to 2010 was equivalent to scooping a single 8-ounce drinking glass of water out of all the oceans on Earth and concluding there are no fish because you did not happen to catch one in that single small sample. A 2018 update to that calculation by a team at the Pennsylvania State University Extraterrestrial Intelligence Center expanded the scoop to roughly the volume of a hot tub out of every ocean on the planet combined. This means our cultural narrative about first contact, the one shaped by Carl Sagan's novel Contact, and Ted Chiang's story of your life in decades of films, stretching from Close Encounters of the Third Kind to Arrival, is built on assumptions that have never been verified by any data we have actually collected. It assumes alien civilizations would approach us as equals seeking communication rather than studying us as a system. It assumes contact would be deliberate from their side rather than triggered by something we did without realizing it. It assumes we would be the recipients of a message rather than the subjects of an observation that may have started long before any of us were born. None of these assumptions reflect how the universe actually has to work. They reflect how humans imagine relationships with entities of comparable complexity, projected outward onto a cosmos that may not share any of our reference points. We have wrapped the idea of first contact in our own story-telling instincts and forgotten that those instincts were never meant to apply at this scale. And then Grok went one step further into territory that genuinely unsettled the team. If a civilization that advanced were ever going to break protocol and reach out directly, the AI had a very specific answer for why that would happen. The reason had nothing to do with friendship or curiosity or welcoming humanity into a wider galactic community. The reason was that something on this planet would have already gone seriously wrong. The intervention threshold. Grok described what it called a planetary isolation breach. The phrasing is clinical on purpose. If a civilization has spent thousands or millions of years passively monitoring developing worlds across the galaxy, it would almost certainly establish protocols for cases where one of those worlds begins to generate consequences that propagate beyond its own atmosphere. The intervention would not be diplomatic. It would be a system-level response to a state change. There would be no negotiation, no embassy, no slow diplomatic exchange of cultural artifacts. There would simply be a measured response to a measured problem. The risks Grok outlined were grounded in concerns that real researchers already track today. Uncontrolled electromagnetic